Hey everybody, this is Miss Eisencraft with Unit 1, Lesson 7, Practice Problems for Geometry. So first problem, which of these statements is true? It's asking us about regular polygons. So I noticed on the Lesson 7 summary, there was a definition. So a regular polygon, something is a regular polygon if it is equilateral, all sides are congruent, the same, and equiangular, all angles are the same. So, in order for something to be called a regular polygon, all sides need to be equal and all angles. So, rectangles. Well, we know rectangles can have longer sides and shorter sides, so that is not a regular polygon. Squares, we know by definition, have to have equal sides. They also have four 90-degree angles, which are all the same. So, yes, all squares. Rhombuses or rhombi are regular polygons? No, because their angles, even though all sides are equal, their angles do not have to be. And parallelograms, when I think of a parallelogram, I think of a long side and a short side. They do not have to be the same. Okay. This is walking you through all the steps for, all the construction steps for making a square, one way to do it. And they're calling this, they're referencing like step 1, 2, 3, and then they use these letters. So I'm going to go ahead and do this. But basically, this is the first example most of us did in class. Okay, so we started with this segment. We made a perpendicular bisector, perpendicular line going through A, which made this line. Then we made a perpendicular line going through B, which went through this line. And then right around step 5, they're going to ask you, why do you need to construct a circle in step 5? And the reason you need to do that, why you're constructing a circle, is so that you're making sure this side of the square is equal to the segment they gave us here. Okay, to make sure the side lengths are equal. So you're setting it to the given segment that was already given to you as the radius. The side lengths are equal. Oh my goodness, to make sure the side lengths are equal. Specifically right here, you're opening it up and then you know where to mark C on this perpendicular line, right? You know where the vertice, this upper left vertice will be. Okay. All right, moving on. Number 3, to construct a line passing through the point C that is parallel to line AB, the first step is to create a line C perpendicular to AB. So we want a parallel line. And if you remember, if you first make a perpendicular line to the original, so let's call this M, this first line M. Okay? If you make a perpendicular line to line M, let's call the new line N. Okay? Now if you take your new line and make another line perpendicular to the new line, it will now be parallel to the original. Right? So we have parallel, new line's perpendicular, then perpendicular to the new line would be back parallel to the original. Okay, so that is, now we need to construct a line through point C that is perpendicular to line CD. So we want it perpendicular to our new line, which was CD. Because then it would go right through there. These not helpful. Okay. Jada wants to construct a perpendicular line to L, okay, through point C. She missed point C. She missed point C. She did the perpendicular bisector where she had the circle share a radius, right? And I think she just started at A, then have that same radius over here. And then, so it was perpendicular, but she missed point C. It is perpendicular though, but not through point C. Okay, moving on. Noah's trying to bisect the angle. Oh, he did a pretty bad job. Okay, he drew 2 circles of the same radius at B and C, so how come it didn't work out? Okay, If you remember, you first need to, well, B and C, in order for this to work, need to be equidistant from A. C looks further away. So what you're going to do is you're going to open your compass, and you can use B and C, or you could start with B or C, or use two new entire points. But let's say you measure A to B. Okay, you're going to have to swing down here with a circle, right? That same radius, and measure where that would be here. And then make a circle with the same radius. Okay, so I think how we would say it is the circles need to be centered at points equidistant from A. C was too far away. Okay, and you can set equidistant points. Use this fixed radius. Use a circle. All right. 6. Here is a straight edge in compass construction. Use a straight edge to draw an equilateral triangle. So there's lots of them in here. And then explain how you know it's equilateral. I'll just do a little guy. There's lots of them. Okay. So if I look at this top left circle, this side is the radius of this top left circle. So is this bottom one, same circle. This is not a radius, but it is a radius of this circle over here. And we know these two circles are the same because they share this radius in the middle. Boom, equilateral. There's a bunch of others too. Okay, here are 2 points in the plane. Explain how to construct. So I'm going to kind of show the steps without real construction tools, because to show you that you could do the constructions even without the tools. So how would you construct a line segment that is half the distance of AB? Well, first of all, I would make a segment. So draw segment AB. Draw segment AB. Okay, and then I would create a perpendicular bisector, because a perpendicular bisector cuts it in half and it'll pierce right through the middle, making the midpoint. So remember, perpendicular bisector, you can just do, have them share the same radius. Okay, have them share the same radius. So you would open it up to AB, draw a circle centered at A. I said I wasn't going to do that, right? So let's say draw a circle centered at A, that goes through B. Okay, and then, so that would be, whoop. Then you're going to draw a circle draw a circle centered at B that goes through A. Whoop. Draw a circle centered at B that goes through A. Okay. Then you're going to mark points where circles intersect. And then draw a line. Draw a line. Okay, so what's going to happen, and I'm doing this just for demonstration purposes. You don't need to do that. It's like kind of trying to imagine it. Draw. Here we go. Right, I'm only going to draw the part I need. Oh my gosh. And B. Ooh. Oh boy. The compass is dancing. Okay. Mark those intersection points. And again, if you could just kind of imagine what that's doing. Draw a line connecting those points. Maybe we'll call them C and D. Connecting points C and D. Okay. Then that line that you just drew or the segment that you just drew will intersect the original segment right in the middle because it's a perpendicular bisector. So then we would know, let's call this like point D. We would know AD is half the distance of AB, and AD and DB are the same because this is the midpoint. Okay. All right. Bye.